This is D. Tommy right here with a video. We're going to be looking at how to get the standard deviation from the frequency table. Let's do a couple problems. Cans of regular soda have volumes with a mean of 12.07 ounce and a standard deviation of 0.12 ounce. Is it unusual for a can to contain 12.47 ounces of a soda? And let's see if that amount will exceed the maximum or minimum unusual amount. So I guess what we'll do first is pull up the calculator. So the first question is, what's the minimum usual value? So we'll take the mean and we will subtract two deviations from it, and a deviation is 0.12. So I took the mean of the weight minus 2 times the standard deviation to get the minimum usual value at 11.83. And we want the maximum value this time. So what I'll do is I'll just do second entry, and instead of subtracting, I'll just do plus and hit enter. 1231. And there might be another question. Well, is it 12.47 unusual according to that range rule of thumb? Well, if it exceeds two deviations from the mean, then yes, it would be unusual. So I'm leaning towards yes, it would be, but I have to pick the right choice. So let's try C first. Yes, because it is smaller than the minimum usual value. It's not quite smaller. Let's go to E. Because it's between the min and the max. No. And then F. Yes, because it is larger than the max. Let's try F. Got it. Next we have this problem. It says find the standard deviation S of sample data summarized in the frequency distribution table. So we don't have the data, but we have the data's frequency distribution table. They would like for us to use for our data, since we don't know it, they want us to use X to represent the midpoint of each particular data point, and we'll use F to represent the frequency. So we have one data point in this interval, one in this interval, 8 data values between 40 and 49. We'll use the midpoint of each class, and so the first thing we'll do is calculate the midpoint of each class. Notice the class width is 10. So once we get the midpoint of one, we can figure out the midpoints of all the other. So let's do that. Again, in this case, we'll use our calculator. First thing I'll do is calculate the midpoint of 20 to 29, and that's just simply the average of 20 and 29. and if you divide that by 2, you're getting 24.5. So I'm going to put that in a list. I'm going to clear this out. Go to Stat, Edit. I'm going to clear this list out as well. Stat, Edit, Clear List, and put in, I think I just forgot what it was. We go back to the home screen. Okay. Let's see. Times it by 2. What was it again? 24.5. So Stat, Edit, 24.5. The next one would be 34.5. 34.5. The next would be 44.5. Let's see. So I did this on this on this one. I have 4 more. And we'll do 84.5. So in one column, I've listed all of the midpoints, and in the next column, I'm going to enter in the frequency, so 118. And let's do 411.34. And let's do 36 to cap it off. All right, looks like we have both of our lists filled. Now what we'll do is go into Stat, Calc, one variable stats, and we'll enter in L1, comma L2. And it gives us the mean, the sum of the x's approximately. Now little sx would be our sample standard deviation. So I got 13.57819212. They want me to round it off to 1 decimal place. So I'm going to get 13.6. Let's see if it likes that. It did. Consider a difference of 20% between two values of a standard deviation to be significant. How does this computed value compare with the given standard deviation of 11.1? Well, let's see. The difference between 13.6 and 11.1, if we were to go back to our home screen and calculate the difference there, I'm getting 13.6 minus 11.1. And if I were to divide that by the original amount of 11.1, this will let me know the percentage of how much it varies. So 2.5 points above. So it looks like the difference is actually more than 20%. So if we consider 20% between two values to be significant, how does our result compare? And what I guess we'd have to say is the computed value is not significantly different from the given value. The computed value is significantly greater than the given value, or the computed value is significantly less than the given value. So it exceeds 20%, and so what I'm going to say is it's significantly greater than the given value. All right, that wasn't too bad. I'm going to check the stream and make sure that I'm getting a message that the key frame rate is slow, so this video may be a little laggy. I'll be back with some more.